All right, in this video, we're going to be doing some verifying trig identities. Now, verifying trig identities is actually very, very similar to simplifying, but we kind of know the answer. Okay, and I'll explain that in a second. And knowing the answer is kind of a good thing, right? All right, so here's the idea. This currently is a trig identity, right? I am basically telling you that the left side equals the right side. Secant squared of theta minus 1 divided by secant squared of theta is sine squared. I'm telling you that. I want you to verify that for me by using the trig identities. So basically, the things you cannot do. When you're doing a verifying problem, you cannot move things left to right. Okay, that's algebra. That's assuming that we know it's true. Remember, we're questioning, is this true, I guess. I'm telling you it's true, but you need to prove it to me. And if you follow the rules of algebra, then you're assuming that it's true. And you can't assume it's true, you have to show it's true. Hopefully that makes sense. So, what I need you to do is start with one side and one side only and work it to make it look like the other side. So verifying is a little bit tricky, but I like verifying because at least you know your solution. So basically, I always start with the side that looks more complicated, because the more complicated side you can usually do more stuff with, and that's clearly going to be the left side here. So basically, this is the answer. Sine squared is the answer to my problem. I just got to show that I could start with this left side and work it to make it look like sine squared. It's actually really, really easy to do. There's actually several different ways you could do these problems. There's not always one exact way. There's multiple ways. As long as you end with sine squared, following your rules, you will be correct. So, strategy I'm going to use here is actually really, really simple. I'm going to use this idea that I have one value on the bottom, so I could divide both values on top by it. So I'm going to take secant squared of theta and divide it by secant squared of theta. And then I'm going to subtract 1 divided by secant squared theta. Basically dividing both of these by secant squared. Remember, I'm basically doing distribution with division. And this is actually really easy. Secant squared divided by secant squared is a big, beautiful 1. 1 over secant squared is, well, you guys should recognize that, cosine squared, right? 1 over secant is the reciprocal of cosine, so 1 over cosine squared. And now I'm looking at my Pythagorean identity, right? If you remember your Pythagorean identity, I'll write it down here real quick. Cosine squared of theta plus sine squared of theta equals 1. So I basically realized that 1 minus the cosine squared, right? If I bring that cosine squared to the other side, 1 minus cosine squared is sine squared of theta. So I was able to work the left side using my rules, my identities, and I found out that I was able to conclude that this crazy secant squared minus 1 divided by secant squared is in fact nothing more than sine squared. Pretty easy, actually. All right, let's try another one here. Now, once again, I'm going to tell you that this is my answer. Now, one thing you cannot do, I've already said this, I'll say it again, you cannot move things left to right. You have to stick with the way it is and show that one side equals the other. So here's how I'm going to do this. Now, as I'm looking at my answer, I'm noticing that there's no sine squareds. So I want to take this sine squared and I want to replace it. Well, I'm going to use the Pythagorean theorem once again. Cosine squared of theta plus sine squared of theta equals 1. That's a true statement. So basically, sine squared of theta is equal to 1 minus cosine squared of theta. All I'm using is I'm taking that identity that I already know to be true, and I'm just maneuvering things around a little bit. Now, why am I allowed to do that here? Because I know this is true. This is something that's just guaranteed. This is a known identity. So I'm going to take that cosine squared of theta, and I'm going to subtract. But instead of writing sine squared, I'm going to replace it with 1 minus cosine squared. Because I know that sine squared is equal to 1 minus cosine squared. Again, using my identities. So let's see here. Now I'm just going to distribute that negative sign there. So that negative sign is going to make a negative 1. And then it's going to make a positive cosine squared. And lo and behold, I'm already at my answer. Cosine squared plus another cosine squared is 2 cosine squareds, just combining like terms there, minus 1. Cosine squared and cosine squared is where I got the 2 cosine squared, minus 1. There's your answer. I was able to take the left side and use nothing more than the identities to get the right-hand side. All right, here's another one. Okay, once again, I know my answer is 2 secant squared of theta. I just got to somehow get that answer working this left side. Well, I see two fractions and a plus sign between them. Well, why don't I go ahead and add these two fractions together? All right, when you add two fractions, you need a common denominator. My common denominator is just going to be taking my two denominators that I currently have and multiplying them together. So I get 1 minus sine of theta times 1 plus sine of theta. Now, this denominator right here, in order to combine these fractions, he needs the 1 plus sine of theta. So I will gladly multiply the top and bottom by 1 plus sine of theta. That way I get that common denominator. And that's easy because there's a 1 there, so that's going to be 1 plus sine of theta. All I got to do there is distribute that 1, right? 1 times 1 is 1, 1 times sine of theta is sine of theta. Okay, back here, this denominator has the 1 plus sine of theta. He needs the 1 minus sine of theta. So I'll multiply top and bottom by 1 minus sine of theta to get that common denominator. Now I'm just going to distribute. That's going to be plus 1 minus sine of theta. Okay, all I did was I got a common denominator, and when you get a common denominator, you have to adjust your numerators a little bit, and I did that. And let's see what happens here. I'm going to do a couple things at once. On top, 1 plus 1 is 2. The sine theta and the negative sine theta cancel. That's easy. On the bottom, I'm actually going to go ahead and multiply that out. Let's see here. 1 times 1 is 1. On the outside, I'm going to get a positive sine theta. On the inside, I'm going to get a negative sine theta, and on the outsides, on the last, I'm going to get a negative sine squared of theta. So I end up with 2 over, well, a sine of theta and negative sine of theta cancel. So I get 2 over 1 minus sine squared theta. And, oh, wait a minute, I recognize 1 minus sine squared theta. We've actually seen the last two problems. So I'm going to continue moving to the right now. I'm kind of running out of room, sorry. I get 2 over 1 minus sine squared is cosine squared of theta. Once again, look at the Pythagorean identity so you can understand why 1 minus sine squared is equal to cosine squared. And then, wait a minute. That cosine squared on the bottom, right, I could treat like 1 over cosine squared. We know that 1 over cosine squared is secant squared. So I can move that cosine squared from the bottom to the top if I use a secant. So I get 2 secant squared theta, and there is my answer. It matches up with what I knew the answer was, so I know I'm done. I have taken the left side, done nothing more than some simple algebra and a little bit of trig identities, and I found that that left-hand side equals that right-hand side. Pretty cool there, pretty simple to do. Not too bad. Now, I know these problems are a little bit tricky, and they take some time, but they're overall not that bad. All right, once again, here's my answer. My answer is negative tangent squared. I need to somehow get that answer working with this left side. Oh boy, let's see here. What can I do? Well, one thing I guess I can go ahead and do is multiply. Tangent squared plus 1 equals cosine squared minus 1. Now, wait a minute. I'm noticing a couple of things here. Look at your Pythagorean identities. I can't stress those Pythagorean identities enough. Anytime you see things that are squared, whether it be sine, cosine, secant, cotangent, tangent, any of those, and you see a 1, you should be thinking some identities going on here, right? For example, I actually see that tangent squared plus 1 is secant squared of theta. That is one of my identities I know. Also, let's see here. Cosine squared minus 1. Well, what is cosine squared minus 1? Well, let's think here. Go back to the Pythagorean identity. Cosine squared plus sine squared of theta equals 1. And just kind of morph this around a little bit, right? If I subtract the 1 over here and then move the sine to the other side, it's going to look like this. Cosine squared of theta minus 1. I subtracted the 1 over. But then I got to subtract the sine squared to the other side. And I get cosine squared minus 1 is negative sine squared of theta. Okay, now I kind of cleaned this up a little bit, but let's keep working here. Let's see here. Secant is 1 over cosine squared. That's one of my reciprocal identities. Times negative sine squared of theta. And actually, I should be clicking. Hopefully you see the answer. Let me pull that negative out in front because I definitely need a negative sign. We know that. And I have sine squared over cosine squared. Well, wait a minute. Sine squared over cosine squared is tangent squared. So there's my answer right there. The negative made it negative. That's easy. You see the sine squared divided by cosine squared. That is tangent squared. Pretty nice and simple there. That one wasn't too bad. Again, I will tell you though, that wasn't the only way to solve that problem. There's multiple ways to solve these problems. All right, this next one is a little bit of a tough one. Let's see here. Here is my answer, secant times cosecant. That's my answer. I need to somehow get there. All right, this is a little bit tricky one, but it's actually not too bad when you start to break it down. First is I'm going to turn tangent into sine of x over cosine of x, and then cotangent is cosine of x over sine of x. All right, now that I got these two fractions, well, why don't we go ahead and add them together, right? In order to add things together, you need a common denominator, so cosine of x times sine of x would be my common denominator. This guy has the cosine of x, so I need to multiply top and bottom by sine of x to get that common denominator, which will generate a sine squared on top. This guy down here has the sine of x. I need to multiply top and bottom by cosine of x to get that common denominator, getting a cosine squared. Well, sine squared plus cosine squared is 1. Okay, that's awesome. That's one of my Pythagorean identities. Over cosine of x times sine of x. Well, wait a minute. 1 over cosine is secant. 1 over sine is cosecant. Voila! I'm done. I took all my identities, I worked the left-hand side, and I got my final answer for the right-hand side. Very, very, very simple. And here's another one. This one's, again, another little bit of a tricky one, but it's actually not too bad if we start breaking it down. Now, I'm just going to tell you, sometimes your strategy could be to actually work both sides. So if you ever get to a point where you're stuck, go and start working with the other side, because if I look at this problem, neither side really looks easier than the other. So sometimes you got to start kind of working both of them. Let's see what I can do here. Secant is 1 over cosine of x. Tangent is sine of x over cosine of x. Oh wow, I already have a common denominator. Why don't I just go ahead and actually multiply these together? So that's 1 plus sine of x over cosine of x. Okay, well, that's not exactly what I'm looking for, but I'm going to stop on the left-hand side right there, and now I'm going to move to the right-hand side. I'm going to use a different color for the right-hand side. All right, let's see here. I'm going to do a really unique strategy on this right-hand side. I'm going to multiply top and bottom by 1 plus sine of x. You're going to see why here in a second. Now, when I multiply top and bottom by 1 plus sine of x, I'm essentially multiplying by 1, so I am not really changing the problem, I'm just multiplying by 1. Now, on top, that's going to generate cosine of x times 1 plus sine of x. That's the top. On the bottom, look what's going to happen on the bottom. I'm going to get 1 times 1, which is 1. Outside, I get sine of x. Inside, I get a negative sine of x. And last, I get negative sine squared of x. Well, the sine and the negative sign cancel. So I get cosine of x times 1 plus sine of x on top. On the bottom, I'm going to get 1 minus, 1 minus sine squared of x. And then I recognize that, right? 1 minus sine squared, if you look at your Pythagorean identities, is cosine squared. So I get cosine of x times 1 plus sine of x, all divided by cosine squared of x. And look what's going to happen here, right? There's 1 cosine on the top being multiplied, and there's 2 cosines on the bottom. So this cosine on top will cancel with one of those cosines on the bottom, leaving me behind 1 plus sine of x on top, and on the bottom I'm going to be left with a cosine of x, because there was 2 cosines, cosine times cosine on the bottom, but one of them canceled. And look what happened. I worked both sides, and I got them down to be something that was the same, 1 plus sine over cosine. So that is another strategy. It's kind of like a last resort. Like if you get to a point where you're kind of stuck on one side, revert to the other side, work it down, and see if you can make them look the same. So essentially, because you made the left side and the right side be equivalent, you can assume, or you could show, that these two statements are verified to be correct. So just make sure that you're very careful that you don't work things left to right. You got to keep everything on one side at a time. You are allowed to work on only one side, or you could work on both sides. You just can't move things back and forth. You can't cross multiply. You can't do any of that stuff across the equal sign. So I like verifying problems because at least you know the answer, but at the same time they just take a little bit of skill, and the more experience you have with them, the easier they will become.